Right, your skills are growing, your tool belt, it's growing. Any elemental material around you, if I give you 0.724 moles of zinc, you could tell me the mass. If I give you 320 grams of nickel, you could tell me the number of moles. I know you're up to it, I know you can do it. But you and I discussed this idea quite a while ago. We looked around the room, we looked for substances that were pure elements, and we didn't find many. Some of you may not have found any. Just about everything around us is a compound, which means it's not made of just one type of element, but multiple elements. Our molar masses, however, from our periodic table, tell you the mass of 1 mole of each element. We've clearly got to be able to work with compounds as well. I'm pleased to say that here your intuition will serve you well. You might think that the mass of a compound could be obtained just by adding together the mass of each component of that compound, each element, and you would be absolutely right. So we can calculate the molar mass of a compound just by adding up the molar mass of each individual element that it's made of. Let's have a look at a few examples together to make sure we've got the right of this. So, in front of you, I have 3 different compounds, 2 or more atoms joined together to make a new material. What we're going to do is we're going to calculate the molar mass of each of these compounds together. The mass of that compound that we would need to have 1 mole of those molecules, to have 6.022 times 10 to the 23 of them. So the magnesium oxide, you'll notice I've popped the relevant element tiles down the bottom of the page for you. So you can see magnesium has a molar mass of 24.31. Oxygen has a molar mass of 16. So all I need to do is add those 2 values together, 24.31 plus 16, and that gives me a molar mass of 40.31 gram per mole. That's all we're doing when we're calculating the molar mass of a compound. A couple of others here for carbon dioxide. Carbon's here, oxygen's here, so that will be 12.01 for carbon plus, and note that carbon dioxide contains 2 oxygen atoms, so it will be the molar mass of oxygen times 2. Add them all up and we get 44.01 gram per mole. One final example there, a larger molecule, looks a little bit scarier, but the principle is exactly the same. So we look up our calcium molar mass from the table down below, that's 40.08. 0.08 plus. Now, got to be careful with our counting here. We've got nitrate here, but we've got 2 of them. So that means we've got 2 nitrogen and 6 oxygen. So our nitrogen, that'll be 14.01 times 2. And for our oxygen, that will be 16.00 times 6. Add that all up and we get 164.1 gram per mole. We can now use these molar masses in our tool belt and our equations just like we would if we got them from the periodic table. Let's go through an example together just to make sure you can see it all in action, no problems. So, in this question, we're asked to calculate the mass of 0.423 moles of dinitrogen oxide. This is laughing gas. It's also the fuel you might see in high-end cars when they want that boost, that nitrous boost. This is the molecule that we're talking about here. So, once again, we're using this section of our tool belt. We've been given the number of moles up here, and we've been asked to find the mass. So we're moving from moles to mass. We'll be using the equation mass equals your number of moles times your molar mass. So this time, it's going to be our number of moles, 0.423, times, and then for the molar mass, what I'm going to do is just come over to the side of the page and calculate my molar mass. I've got 14.01 for nitrogen, and there are 2 of them. I've got 1 oxygen, that's 16.00, so I can add that all up and I will get 44.02 for my molar mass. So I can now use that in my equation, and that gives me a final mass of 18.6 grams. So as you can see, there's very little that's changed in our approach here. All we've had to do is an extra calculation on the side to find the molar mass of our compound. The mass that 6.022 times 10 to the 23 molecules of that substance would have. Right, our powers have grown. They have grown quite substantially at this point in time. We can now take any solid substance around us, be it element, compound, whatever. We can go from mass to moles, we can go from moles to mass. We're getting closer to our ultimate goal. The next topic, we're going to talk a little bit about solutions, but in a couple of topics' time, we're going to start looking at how we can combine all of this and use it to do some really powerful stuff.